Hello, geometry. So today we're going to go through similar polygons. Now this concept is actually pretty difficult. The first part of it is not so bad, but you do need to make sure you're really paying attention to all the details today. Okay, so similar figures are the same shape, but may not be the same size. There are two parts to similar polygons. The other thing is the notation. So what you'll see is the symbol, which is just the squiggle. So that is a similarity symbol. And you can compare that to, for example, down here, the congruence symbol. Congruence has an equals with a squiggle. Similarity is simply just the squiggle. Okay, but there are two parts to similar polygons. And both of these need to be true in order for the shapes to be similar. Okay, the first one is says that corresponding angles are congruent. Okay, and then the second part is that the corresponding side lengths, now this is the part that's different than congruency, corresponding side lengths are proportional. So it's no longer that the side lengths are congruent, it's that they have the same ratio for corresponding sides. Okay, so we're going to start using proportions and ratios when comparing similar polygons. Okay, but the same rules apply here for similarity. Notice that you have this similarity symbol, that squiggle. But the same rules apply as far as keeping the letters in order. So here, if we know these two shapes are similar to each other, then angle A would correspond with angle G and therefore would be congruent. So I'd say angle A is congruent to angle G. So using that same logic, pause and write the rest of these congruencies. Okay, so you should have angle H goes with angle B, angle C goes with angle I, and then angle D goes with angle J. So D goes with J. So that's the first half of the definition. The corresponding angles are congruent. Okay, the second part is this crazy big fraction equals equation thing. So this is showing that the corresponding sides are proportional. So you put them into ratios and set those ratios equal to each other. Now, same thing applies as far as the order goes. Notice that AB is right here, AB, and that is corresponding with GH. So the next one, next fraction or ratio would be BC. So BC, and that would go with HI. Okay, so pause and do the other two ratios. Okay, so you should have CD goes with IJ, and then wrapping around DA corresponds with JG. Okay, so what that means here, and I'll just give you an example of how this would work. But let's say that AB is equal to 2 and GH is equal to 4. Okay, so let's say that those are 2 to 4. Okay, all of the other fractions would also be in that same ratio. If you reduce the ratio, it's 1 to 2, or 1/2. Okay, so maybe this one's a 1 and that one's a 2. Maybe this one's a 4, that one would be an 8. And then maybe this one's a 3 and that one would be a 6. Okay, but all of these corresponding sides would all be in a ratio of 1/2 if you reduced them. So you have the 1/2 BC to HI, CD, so 4/8 And then lastly, the dA to JG is 3/6. But all of these reduce to 1/2, and therefore they are proportional. Okay, so that's how this works here. The angles are congruent, but the side lengths are in the same ratio, or in other words, they are proportional. Okay, so using another example here. So given the statement here, triangle MNP is similar to triangle SRT. That is called a similarity statement. People tend to forget that's what it's called. So let me highlight that. That is a similarity statement. Okay, so what you're going to do is make all of the angle congruency statements and then write the extended proportion. So pause and give that a go, just like on example 1. Okay, so again, you're just going to do these in order. So M goes with S. Angle N corresponds to angle R. Angle P corresponds to angle T. Okay, you could also mark it in the picture. So M corresponds to S. R corresponds to N. And then angle P corresponds to angle T. Okay, and then if you wrote the extended proportion, MN goes with SR. Okay, NP goes with RT. And then PM goes with TS. Also notice that I am being consistent with each of these ratios. Every single one of those ratios, I compare the small triangle to the bigger triangle. Now, you can flip-flop that, but that would mean we would switch the statement. So what I mean by that is, for example, if I was given triangle SRT is similar to triangle MNP. So if I was given that, I would generally write this triangle's information on the top and this triangle's information on the bottom. So all that would do is be switching the fraction. So notice that this fraction is just flipped because the bigger triangle is now the first one listed. Okay, and that would go for all of the fractions. So just pay attention to which is listed in the ratio or in the triangle statement, and take that as a hint on what goes on top and what goes on the bottom. Okay, next ones. So now we're going to compare and see if the polygons are similar. So remember, there are two parts to this. The first part is, are the corresponding angles congruent? So notice that things are marked congruent here, here, here. Those right angles are congruent. And then the L and the V are congruent marked. Okay, so I'll just abbreviate it, but corresponding angles are congruent. So we have that part checked off. That is part. Next, we need to figure out if the corresponding sides are proportional. So these two shapes are oriented in the same direction. So I'm going to pick corresponding sides. So this side here, MJ, corresponds with WT. You can tell because of the angles. Notice how these angles are marked. These angles are marked the same way. So I know those two sides correspond. Okay, I'm going to do a different symbol around the next shape. I'll do a square around it. But notice the angles marked. That's how these are marked. So this side goes with the 12. So I have 6 corresponding with 6. And then here I have 12 corresponding with 6. And it should be fairly obvious that those are not congruent. Okay, there's a couple of ways you can tell. You can reduce the fraction, that's equal to 1. and that's equal to 2. And then another way you could do it is you can cross multiply and see if the cross product is the same. But here 36 is not equal to 72. Anyway, so without having proportional side lengths, we would answer no, not similar. So these two shapes here are not similar because you need both things to be similar. Okay, the next one. So again, we have markings in the angle. So this angle is congruent to this one. This D is congruent to A, and then B is congruent to E. So we have that part taken care of. Corresponding angles are congruent, check. Okay, and now we're going to check on corresponding sides. So again, if I look at the angles, how they're marked, 8 corresponds to 10. So I'm going to start with 8 over 10. Okay, next I have this angle and this angle is 12. I'll make that a square. And then between the double and the triple, I have 15. So now I have 12 over 15. Okay, we can just check really quickly that those are congruent, because if they're not, then we don't have to even have to check the third part. Okay, so this reduces to 4 over 5. If you divide them both by 2. And then this is equal to, so if you divide them both by 3, you also get 4 over 5. Okay, so far, these are proportional. But now I have to check the third side as well. So the 16, put a triangle on that one, would have to go with the 20. So now I'm going to try 16 over 20. If I divide them both by 4, I get, again, 4/5. So that checks out as well. So this is a yes. These are similar. And now I need to do a similarity statement. So similarity statement for these, you can use the triangle symbol. And remember, the first way you write the triangle, it doesn't matter how you do it. So maybe I'll say CAB. And then remember, you're doing just the squiggle. And then next, so I have to have corresponding letters on the second. So pause and try to do that yourself. Okay, so angle C is marked the same as angle F. So F would come first. Angle A is marked the same as D. And angle B is marked the same as E. So this would be my statement. Okay, and then my scale factor or similarity ratio would be the reduced version of the fractions. So in this case, my similarity ratio would be 4 to 5. Okay, last one. So here, you're given the similarity statement. So I already know these are similar to each other. And then you want to look for where you have given information. So I have given information at EH. So EH corresponds with JM. Okay, so EH corresponds to JM. And we know that is going to be 16 to 24. And I'll even circle those like I did above. So these correspond. Okay, the 20, the GH, goes with LM. Okay, so GH goes with LM. And GH is 20, I'll put box around that. And LM is X. So I get 20 over X. Now, because I know they are similar, you can set up 16 over 24 equals 20 over X. And then at that point, you are going to cross multiply. I'm going to do that quickly, but X should be 30. So you cross multiply, you can use a calculator, but that should be 30 inches. All right, good job. This is tough.